So hello, welcome to your first flipped lesson. Today we're going to be talking about solving systems using Cramer's rule and matrices. So we sort of talked about this already, so it shouldn't be too much of a new concept, so I think you should be fine with it. Had we been in class, we just would have done a few extra problems, which most of these are the problems that you're going to be doing. I'm kind of glad that you're seeing not the performance, but the workshop today, because I think it should be very good for you. The assembly will be very beneficial. I think it's about a really good topic that you should know about. So in a way, I'm kind of happy that you're going, but of course, I'm disappointed that you're missing math class. So here are the lessons. Just like if we were in class, I expect you to go through and do all of the problems in your notebook and check the answers as we go along. So make sure you have your notebook and your pencil and your calculator with you so you can go ahead and do these problems as you follow them along on the video. So here's the first one. We're going to be talking about Cramer's rule. Well, actually, here's what we did the other day. Notice that when we're doing these problems, we are talking about using Cramer's rule, and Cramer's rule is written here. This time it is the Cramer's rule that we're going to be talking about is the Cramer's rule that we had for 2 dimensions as opposed to, well, we did 2 dimensions, now we're doing 3 dimensions. Notice that right here, that is our coefficient matrix. So in this column are all the coefficients of the x, this column is all the coefficients of the y, and this column would be all coefficients of the z. Then I would find the determinant of that. So I would write over the first 2 columns, the column with the a in the top and the column with the b on the top, and then I would find the determinant by multiplying these 3 ways, and then I would add those together and then go up this direction and add those together and subtract the 2, and that would give me the determinant. So then in order to find the x value, I'm going to replace the column which had the x coefficients, and instead I'm going to put my constant coefficients in there. I'm going to leave my y and z column the same way. Then I'm going to do the determinant for that using the same process that we did before, and then take that determinant and divide by the determinant we got when we had the coefficient matrix. I'm going to do the same thing for the y, except I'm going to replace the y column with the constants that I have in the y's. And then I would take the determinant of that matrix and divide by the determinant of the other matrix, of the coefficient matrix. And then for z, I'm going to do the same thing. There's my z column, and instead of having the z coefficients, this time I'm going to have the coefficients, or the constants there. So it's basically the same thing that I did when I had 2 dimensions. Now I have 3 dimensions, and it's completed the same way. So if we look at the next equation, here's my Cramer's rule. So I'm going to set up my coefficient matrix would be interesting because those are not the numbers that go with here. Oh, I see what I'm doing. Okay, never mind. I see. My coefficient matrix is down at the bottom. So here's my problem, and you probably want to copy it down. So I have 2, -1, and 1, 1, 2, and 1, and -1, 1, and 2, and that would be my coefficient matrix. I put those in the denominator of all of them because we're going to be dividing by that. And then I would have my, this would be my x value. So to find x, I would put in the column for my x's, and then I would find the determinant of that divided by the determinant of the coefficient matrix. Here would be my y's, so that over here was for x. This is, we're agreeing with me here, that's x. This one's y, and then this one's z. So I would go ahead and do that. So make sure you pause the video for a second and actually calculate all of those determinants out. When you do that, come back, and you should see that our answer, when I do that, I will get 6 divided by 12. So the x matrix determinant was 6, and the coefficient matrix was 12. So I get 0.5. If I take the the y coefficients, I would get 12. So I'm going to have -12 over 12, so get -1. And then my z's would be 24 over 2, or 24 over 12, which is 2. So that means the solution to my system is 0.5, -1, and 2. And I can find that and double check it by doing substitution or elimination if I wanted to. So here's our last problem. Here's my Cramer's rule. So I have 2x plus y plus z equals 5, x plus 4y minus 2z equals 9, and 6x plus 5y equals 16. Now you have to remember that all of the variables have to line up. So I have my x's in my first column, the y's in the second column, and the z's in the third column. But since there's no z for the last one, I need to remember to put a 0 in there to sort of hold the spot. So there's the determinant for the coefficient matrix. And you can go ahead and double check my math, make sure everything's correct, do it for yourself. And you should see that you get negative 11. Then for the next one, I would do the y's. Oh, and hopefully everybody's copied that problem down. I shouldn't have to say that, but hopefully you have, so that way you'll be able to solve the rest of it. If you need to, you can pause. So then if I scroll down, there's going to be my x. I'm going to take my x determinant. And when I do my x determinant, I'm going to do the x divided by the y's. Sorry, the x divided by the coefficient, so I get 1 over 11. I know, not a nice number. It's okay. Then I'm going to do the y's, the same thing. And when I end up with that, my answer is 34 over 11. And then when I do the z's, I'm going to end up with positive 19 over 11. So although it's not a nice answer, it's not very pleasant looking, the fractions are okay. And those are both, they're all 11s down there. I'm not quite sure why they look kind of like 17s. So that's the process that you're going to go through. You can go ahead and just double check each of those particular ones. There's my y and my z, so you can see it if you need to go back and look and see all the math that's going on there. That's basically what you're going to be doing on homework tonight. So here's the homework. You're not doing the next homework on the assignment sheet. Instead, what you're doing is you're doing the homework that is on this paper, on this video. So make sure you do the correct thing for homework tonight. So here's the homework. I want you to do page 196, numbers 51 to 54. And then the next time, we will be doing something else. Make sure you bring your graphing calculators, because the lesson that we're going to be doing is on inverse matrices with graphing calculators. So you need to make sure you have that. So bring that to class the next time I see you. Have a wonderful night, and I'll see you next time.